Hey everyone, we are going to get started with our kinetics unit and just briefly discuss collision theory and the factors that affect reaction rates. So this is going to tie into the video that you watched yesterday and answer questions on. So some of this will be review for you. So just keep in mind we've talked about how when two particles collide, there has to be a collision in order for a reaction to occur, but not all collisions will actually be effective and result in a reaction. So in order to have an effective collision, one that actually results in a reaction, the molecules must be orientated properly in order to react. And that's what this is showing over here. So in order for this chlorine atom to react with this molecule, the two chlorines have to be able to collide, which will then form a bond here. And then it also is going to break a bond between the chlorine and nitrogen. However, if the chlorine reacts with the oxygen side, that orientation, which is going to be ineffective, is just going to basically bounce off of each other, and then it doesn't result in a reaction. In addition to the orientation, any collision has to have enough energy, okay, which we're going to talk about in future videos, which you want to think of as activation energy, the energy needed to start in order to react. So let's talk about how reactions can either be sped up or slowed down. So we're going to be talking about reaction rate, and this is simply the speed at which a reaction is transformed into a product. Keep in mind, a reaction is always both the breaking and the forming of bonds. You're going to see kind of repeated over and over again that anything that can speed up the rate of the collisions will increase the rate of the reaction. So the first little thing, it has to do with the nature of the reactants. Because we're dealing with breaking and forming of bonds, that bond type is going to affect our reaction rate. Usually you're going to look for ionic reactions, especially if they're aqueous. Those tend to occur faster than your covalent reactions. That has to do with that type of bond and what's involved with breaking and forming them. So that's the first thing. Ionic is going to be faster than most covalent reactions, especially if it's aqueous. All right, number two, concentration of reactants. This is a condition that you could pick out in terms of setting up a reaction. So as the concentration of reactants increase, and keep in mind concentration has to do with the number of particles. The higher the concentration, the more particles. So if you look down at this bottom diagram, maybe let's say this would be like a 1 molar solution versus this one, which maybe would be a 3 molar solution. Okay, so the higher the concentration, the more particles. Well, if you have more particles, that means the number of collisions is going to increase. And anytime you cause more collisions, that means that the reaction rate will also increase. Okay, if you're packing more particles into a space, there's more collisions that's going to occur between them. Also keep in mind, if you're talking about gas samples, increasing pressure on the gas samples is going to be the same as increasing the concentration because you're pushing the particles closer together. All right, moving on to temperature. Remember that an increase in temperature is an increase in your average kinetic energy. Okay, remember kinetic energy has to do with speed. So as the temperature increases, the particles are moving faster. And if they're moving faster, that number of effective collisions is also then going to increase. So maybe at this lower temperature, maybe you would be at, say, 273 Kelvin. And then at this higher temperature, let's say we have 303 Kelvin. Okay, if they're moving faster, there's more collisions, so the reaction rate is going to increase. One little thing with temperature is that we're going to find out that it isn't just that they're moving faster, but there's also going to be more particles that have enough energy, which allows there to be even more effective collisions with temperature. So temperature is a really important one that we'll come back to. All right, number 4, surface area. And this is one that students tend to struggle with because of how I think they picture the particles in their minds. So surface area relates to the number of particles on the surface that can collide. So if you look down at this picture, this would be like one clump of magnesium or maybe a strip of magnesium. If you think about what can react, it's only these particles on the outside. Okay, they're shielding the particles on the inside. However, if I break it up, okay, so I break up the particles They're spread out. So maybe this would be making a powder of it or cutting up the little strips into various pieces. Once you do that, then look at how they're exposed. All particles are exposed and can result in a collision. Okay, so whenever you increase surface area, okay, you're going to be increasing the number of collisions. So this will be increase. Now keep in mind, if you have a powder where the particles are all spread out, that has more surface area, okay, than the same compound as a chunk or a cube. So keep in mind, powders always have the greatest surface area. All right, so just to fill in the last part here, as the surface area increases, so there's more particles actually exposed, okay, the number of collisions will increase and the reaction rate will also increase. Okay, and then our last one that we're going to talk about, the catalyst, and this is similar to the video you watched yesterday with the matchmaker. It's not an actual reactant. It's not consumed by the reaction. It simply changes the steps of the reaction. It's basically like creating a new pathway. So the addition of a catalyst is going to increase the rate of the reaction. So this is a common Regents question where we'll say, how does a catalyst increase the rate of a chemical reaction? So the wording of this is just because you might see this in various Regents questions, would be that it creates an alternative reaction pathway. Alternative reaction pathway. And it's not that it just creates this different pathway. This pathway is going to lower the energy needed for the reaction to occur. So it creates an alternative reaction pathway that lowers the activation energy. And again, this is just the energy needed for the collision to be effective. Okay, if they need less energy, there's a higher probability that they're going to be able to react when they collide. All right, so you need to know, just to summarize the collision theory, okay, what makes a collision actually result in a reaction, and then the 5 ways to either speed up or slow down a reaction. And just keep in mind, if those conditions for a reaction create more effective collisions, the reaction rate is going to increase or occur faster.